This video will go with 10.2b notes from 2019 Algebra 2. We're going to focus on finding the sum of an arithmetic series. So remember, an arithmetic series is one that changes with a common difference. The formula for the sum of the arithmetic series is given here. S sub n equals n times the quantity a sub 1, the first term, plus the nth term divided by 2. So we're going to have to find a couple things. First of all, remember that if we want to find a sub n, that's the nth term, so we will need to find the equation for the series and then be able to find the nth term. So we want the sum of the first 25 terms. That means that our n will be 25. So I'm looking for S sub 25, the sum of the first 25 terms. Remember that a sub 1 is your first term. So in this example, our a sub 1 will be 20. And we will need to find our a sub n, our a sub 25 for this part of the formula. So since we need to find a sub 25, we need to find the formula for our series, our a sub n. So remember the general form is dn plus a sub 0. So our common difference times our n plus our term before the first term. So if we look at our series, we're going from 20 to 18, 16, 14. So it looks like our common difference, we're subtracting 2. So we're going to have a common difference of minus 2. Then if we go backwards, if this is our first term, our term before the first term, our a sub 0, since we're subtracting 2, adding 2 will give us 22. So a sub 0 will be 22. So we can write our a sub n equation as negative 2n plus 22. Then we can use that to find our a sub 25, our 25th term. So a sub 25 will be plugging in 25 for n. It's negative 50 plus 22. Should be negative 28. So the part that I highlighted up in the formula, that's going to be what that term is, a sub 25. So if I want to find the sum of the first 25 terms, it's going to be 25 goes in for n times the quantity. The first term, remember, which was 20, plus the 25th term, it was like a sub 25, all over 2. So the 25th term we solved over here was negative 28. And then we find the sum of those and we divide it by 2. So do what's inside the parentheses first. So that's going to be on top. We get negative 8. And then negative 8 divided by 2 is negative 4. And negative 4 times 25 is negative 100. So if you think about this series as it goes, it's going to continue to get smaller, and eventually the terms will turn negative, and so that's why our sum ends up being a negative number. So the sum of the first 25 terms will be negative 100. Okay, so here's the series, arithmetic series, 2, 6, 10, 14. So a couple things. We want to find the sum of the first 20 terms. So right off the bat, we know that a sub 1 will be 2. We know that we're looking for the sum of the first 20 terms, so we know that n is 20. We know that we'll need to find a sub 20, the 20th term, for a sub n. And that means we'll need to find the formula, a sub n, dn plus a sub 0. So what's our common difference here? 2, 6, 10, 14, we're adding 4. So our common difference, our d, is positive 4. And then a sub 0 then, if we go backwards from the first term, so minus 4, we're going to have a sub 0 will be negative 2. So a sub 0 will be negative 2. So my formula for a sub n will be 4n minus 2. And I can find a sub 20 then by plugging in 20 for n. Okay, 80 minus 2 is 78. So now I have enough information to find the sum of the first 20 terms. So I'm going to plug in 20 for n. I'm going to plug in 2 from over here, 2 for a sub 1, plus a sub n. Remember that was a sub 20, so the 20th term was 78. So plugging in 78, it's all of that divided by 2. And then just working through the math here, we're going to have 20 times 80 divided by 2. So 20 times 40, 2 times 4 is 8, and add 2 zeros. So the sum of the first 20 terms of this series is 800. Okay, it'd be a good place to pause the video here and try this one on your own. And then unpause and I'll walk you through it. So I like to write down the information that I know right away. So I know that the first term is 30. I know that my common difference, I'm going from 30 to 25, so I'm going down, and I'm going down by 5, so my common difference is negative 5. I want the sum of the first 14 terms, so that means that my n will be 14. I'm going to need my a sub 0 term to write my formula. So if I go backwards from the first term, a sub 0 will be 35. And then my formula for my equation to find my nth term, so I need to know my nth term, or my 14th term, will be dn plus a sub 0, so negative 5n plus 35. That means my 14th term will be negative 5 times 14 plus 35. So a sub 14, my 14th term, will be negative 70 plus 35, be negative 35. So up here we're going to have n, and then it'll be a sub 1 plus a sub 14 all over 2. If I plugged in 14 for n too. So if I just plug in the 14 for n. So I can use the sum of the 14 terms, plug in 14 for n. The first term was 30. The 14th term was negative 35. All divided by 2. 14, negative 35 over 2, or negative 5 over 2. So 14 times negative 2.5. And I end up with the sum of the first 14 terms is negative 35. We again end with a negative number because here's the first 4 terms, and then we're going down by 5, so 15, 10, 5, 0. So 3 more terms we're going to be at 0. So that means the first 7 terms are positive, but then the next 7 terms are negative. So we end up with a sum of negative 35 when we add them together. Okay, when might we use an arithmetic series and a sum of an arithmetic series? So here's an example using an arithmetic series. A construction company is laying a natural gas pipeline. Several sections of the pipe have been laid in a pile at the construction site. There are 12 sections of pipe in the bottom row of the pile. Each row has one less pipe than the row below it, decreasing arithmetically. There are 8 rows of pipe. Write a rule for the number of pipe sections in the nth row. Find the number of pipes in the row 8 and find the total number of pipes in the sections in the pile. So let's read here is the information that we need. There are 12 sections of pipe in the bottom row of the pile. Each row has one less pile than the row below it, decreasing arithmetically. And then there are a total of 8 rows in the pile. So if you can imagine that, there's 12 sections of pipe on the bottom, and then there would be 11 sections of pipe in the next row up, and then 10, etc. So it's one less pipe than the row below it, decreasing arithmetically. That means my D will be -1. And there are 8 rows of pipe, so that means my N is going to be 8. So writing a rule for the sections of pipe in the nth row, they want me to write the rule A sub n, dn plus A sub 0. So A sub n, D is going to be -1, so -1n, and then if it starts with 12, the term before that would be 13. So my A sub 0 is going to be 13. So since I'm subtracting 1 every time, I go backwards by adding 1. Find the number of pipes in the 8th row, so they want A sub 8 essentially. So if I plug in 8 into my equation, I'm going to get -8 plus 13. In the 8th row, there are only 5 pipes. Remember, it's decreasing every time, so the very last row has 5 pipes. Find the total number of pipes in the pile. So they want us to add up every row. And we can add up every row by finding the sum of the first 8 terms of this series, because there's 12 in the first row, 11 in the 10th, in the next row, 10, etc. So if we find the sum of those 8 terms, we essentially are finding the sum of all of the pipes in that pile. So we need to plug in, it'll be n, well, we'll plug in 8 for n, and that'll be the first term plus the 8th term all over 2. And we already found the 8th term because we found A sub 8 up here was 5. So it'll be 8. The first term, remember, was 12, plus the 8th term is 5. Find the average of that, divide it by 2. So 12 plus 5 is 17 over 2. And we're going to end up with 68 pipes total. So there's where we can use some of an arithmetic series to solve a problem when we're looking for a total number of things. Okay, that's it. Just finding the pieces of the formula and plugging them in correctly. Thanks for watching.